Welcome to College Algebra. In this lecture video, we're going to talk about combining functions. So we're going to do two things here in this video. We're going to talk about operations of functions, and we're going to talk about something called the composite functions. All right. So our functions is able to add, subtract, multiply, and divide. So we're going to take a look at operations of functions first. Alright, so let's say I got two functions here, okay, f of x and g sub x. So f of x is a cubic function and I got a linear function here. So the problem here says find f plus g of -2. So what I want to do here is adding the two functions first, then whatever answer I get, I will evaluate it at -2. That's what the problem is saying. So my function f is x to the third minus 7 plus my second function, just one term, so I can just put x. So this is the combine of the two functions. So my answer, x to the third plus x minus 7. Okay, so this is my new function after I combine them. So now I'm going to evaluate at -2. So to evaluate at -2, I can either put in the calculator, graph this cubic function, go to the table, or I can just gonna write it out. I'm gonna write it out. -2 to the third power plus -2 minus 7. So make sure you can write it out correctly. So let's see what's our y value gonna be. Plus a -2 minus 7. Alright, so the y value -17. Okay. Now let's find f minus g and then evaluate at -2. So what you do not want to do is plug in -2 and -2 in this function right off the bat. What you want to do is add up the two functions first, which will give you a new function, then evaluate -2 at the new function. Now watch out for the subtraction, okay, because that's a negative sign for your second function. So my first function, no problem, x to the third minus 7. Minus my second function is only one term, so I can just simply put x right here. So I get x to the third minus x minus 7. Alright, so now I'm going to evaluate at -2. So this time I'm going to actually graph this function so I can demonstrate different ways to evaluate your function. Kind of refresh your memory on this a little bit. X to the third minus x minus 7. Alright. I'm going to graph it. Here's my cubic function. And -2. My y value is -13. Okay, that's all it is. Alright. Multiplying the two functions. So remember now, my first function is two terms, so that's x to the third minus 7. Two terms represent one function. Put them in the parentheses so I can multiply my function g to just x. If I do a distribution, I will end up with x to the fourth power minus 7x. So now I have a quartic function. X to the 4 is a polynomial function. Quartic function. So from previous lecture videos, you know, polynomial function with an even exponent. Okay, give an idea, it might be like a U shape. So I'm gonna graph it. X to the fourth minus 7x. I'm gonna delete that. Wrong button. I'm going to evaluate at -2 again. So this is a U looking thing. Y value is 30. Okay, so my answer will be 30. All right, dividing two functions, so I can add, subtract, multiply, and divide any given two functions. So dividing is a little bit difficult sometimes because many of us don't really know what we're looking for when we write out division of two functions. So if you write it out, we're gonna have x to the third minus 7 whole thing over x. So Mr. Jiang, how do I simplify this? Well, it really depends on what we are having here. When we talk about simplifying, what you want to do is make sure there's no other fractions inside your fraction function here. Okay, inside your rational functions. So in this case, we don't have any fractions on the numerator or denominator. So now when we come to simplifying, which is during the review, we're talking about try to factor these, see if anything can be canceled. In our case, nothing can be canceled because there's no common factor for my numerator. Denominator is only one term, so this is actually the simplest form as it gets. So now I need to evaluate at -2, so I can plug in -2. Okay, it will give me some kind of answer. I'm gonna do this by hand. Over -2. Alright, so because that's only one term, I can simply put -2. -2 whole thing to the third is -8. -8 minus 7, -15 over -2. So this is going to be 15 over 2. 7.5. Okay, 7.5. Now, to graph this function, okay, we got to make sure the calculator to see these two terms as one numerator. Put them in the parentheses. Alright, divided by x. Whoa, what's going on here? There's a weird looking picture in it. So this is not like the one we seen before. Because before, with a rational function, we have 1 over x to the even power over what? I power, which is different from this problem, because this problem is actually third power on the top, 1 power in the bottom. Oh, this is a weird looking thing here. Make sure I don't have anything else here. Okay, no. So if I go to table, go to -2, okay, I still get my 7.5. This is a one wicked looking picture here. And we will talk more about this. We will actually talk more about this one. Now, I'm going to try something here. X to the third minus 7 in the parentheses. This time I'm going to put this x in the parentheses. Let's see if our picture change. Nope, doesn't change. Still looking the same thing. Okay, so exactly what we are looking at. I'm going to go to zoom and kind of zoom out. There you go. Just look like this. Okay, kind of weird looking thing. I'm going to go back to my standard window. Okay, so this picture is weird. We'll talk more about these type of problems, okay, down the road. Alright. Let's combine more functions. Alright, greatest integer function right here. This is a square root function. Find the formula for f plus g of x and simplify your answer. Then we're gonna find the domain, okay, for our new function. Okay, run to 2 decimal places if necessary. So take my first function f plus my greatest integer function. And I think this is all we can do right here. Because you know, this x minus 5 is inside these bracket, and this is inside the square root, so there's not much I can do here. So this is basically it. Now, how do I find the domain? Now let's graph this thing. So I got a square root function and the step function put together, basically. Square root of x plus 1, close parenthesis, plus, go to math, highlight the word number, integer, x minus 5, close it. So I got some steps, here's my steps. Okay, that's all it is. Alright. So, what's going on? What does the minus 5 mean? What does the minus 5? We mentioned, I asked you to check this thing out with the greatest integer function before. You know, what does this minus 5, you know, and the minus 5 kind of tells us that it has been shifted. The step function has been shifted over 5 places. If I go to my table, okay, if I go to my table, you see I have a step function here. I don't have any step function starting in the negatives. My first value, my first y value known is -1, because inside the square root function, if I set what's inside the square root function equal to 0, x will equal to -1. And as you can recall, that's how we know where the function began for the domain. Alright. So now if I will plug in -1 here, -1 plus 1 is actually 0. Square root of 0 is 0. If I plug in -1 here, -1 minus 5 is -6. So the greatest integer we're going to begin is at -6. That's why the y value says that. Alright. So now my domain, my starting at x value, keep on going to the right based on the graph. Keep on going to the right. So that would be bracket -1 to infinity. Alright, so the minus 5 just make the step function shifted over 5 places, but the domain is still starting from -1. Alright, same thing with division. There's not much you can do here once you write it out. That's square root of x plus 1 over the greatest integer function. I'm just going to do one bracket for right now. X minus 5. Alright, let's check it out. What this thing look like. I'm just going to put this as a division button. Just to be on the safe side, I'm going to throwing some parentheses for my denominator. Okay, throw a parenthesis outside this integer function, just be on the safe side, so the calculator can see this as one term. Right now the calculator see the numerator as one term already, because there's nothing outside the square root. So ooh, interesting. I'm gonna kind of make my window a little bit smaller real quick. I don't have anything on the negative side, so I'm going to start from 0. The y minimum, I'm going to do -5 to 5. Just take a peek. Okay, that's just one weird looking thing. It's almost like a step function, a little bit. A little dip right here, like a square root function some sort. Okay, so let's see if my domain still starting at -1. Sure does. Okay, because everything else before -1 is an error. Okay. From -1 to infinity. Keep on going to the right. Okay. Now let us test something out, because all these are whole number. Ooh, there's an error on 5. Okay, why is there on 5? 5 minus 5 here will actually give it a 0. Ooh, So this is not correct. It's actually from -1 to 5. Union from 5, keep on going to the right. Alright, so if I go to my table, excuse me, second count number 1 value, if I type in 5, my Y value will say nothing. If I type in -1, my Y value said invalid. Alright, let's do some other decimal. Let me pick a 6. Like 6.01. Yep, there's a Y values up here. Okay. Alright. So be careful now, be careful. I did not check the denominator. Gotta check the denominator too. Okay. So the -1 tell me where I start, but my restriction on the domain got to be this 5, because the 5 minus 5 will give me the 0. Alright. Let's try this one. Multiplying. Okay, earlier we will actually we add 1 and divide 1. Absolute value function times square root function will simply be absolute value of x times square root of x plus 2. There's really not much you can do, because you can't distribute this x in there, because this is inside the absolute value. Alright, find the domain. Okay, let's graph it. Mass absolute value number 1 of x, close the parenthesis, times square root of x plus 2. Close parenthesis for my square root. V times, oh, sorry. Let's go back to the standard window. So number 6. Alright. So if I set was inside my function equal to 0, okay, that x will be equal to 0. If I set my x plus 2 equal to 0, that x will be -2. So this problem tells me that I will probably start at -2, because the 0 is actually bigger than the -2. Let's go to table and check it out. So 0 is okay, because 0 times anything is still 0. 0 plus 2, square root of 2 is some kind of value. So that's legit. Now, -3 is not legit, because the -3 plus 2 is already not real. Not real number cannot times real number. Okay, so my domain, starting from -2, keep on going to infinity. Okay, yeah, let's keep on going to the right and up. Alright, let's try different ones. So multiplying, there's not much simplifying to do, because they are not really taking a polynomial times another polynomial. Alright, this is a division one, so watch out for my restriction on the domain. Function f is a cube root of x over x plus 5. Alright, so there's only one x inside the cube root, so nobody can go out. So this is as the simplest form as I can have. So if I set was inside the function equal to 0, inside the cube root equal to 0, my x is equal to 0. To give me an idea of where I may start. My restriction on the domain, x plus 5 cannot be 0. Therefore, my x cannot be -5. Alright, I do all that for the domain part right here. So as far as step 1, this is the answer. Okay, so let me move these guys downward. Alright, let's graph it. I have no idea what this thing look like. Go to math, number 4. Cube root of x. Close parenthesis, then I divide it by. Denominator is 2 terms. Represent one denominator. Put it in the parenthesis. Oh, it's a rational function. Yeah, that looks like a rational function. Now this part right here stays right above the x-axis. Okay, so your y value is very close to be 0, but it still keep on going to the right. So if I go to my table, okay, at -5 is an error. Okay, but if you keep on looking at the x value being more negative, my graph actually keep on going more left as well. Just cannot be -5. If my x value keep on going to the right, okay, my y value is actually getting smaller and smaller. But as far as domain concerned, my x value is allowed to keep on going to the right. Oops, sorry. So for this problem, once I keep on going left, once I keep on going right. So this problem is not asking for the range for a reason. Okay. So my domain is going to be from -infinity all the way to my restriction on the domain, because it was an error there. Use parenthesis, union, or my domain can be from what, the other side of 5, excuse me, -5, keep on going to the right. Alright. And my calculator does confirm that when x cannot be -5. Alright, so we did not do a lot of simplifying because these are very different kind of function being divided or added, subtract, multiply. So it's not much simplifying to do. Certain problem we will simplify more than others. It really depends what type of function we're dealing with. Now, let's take a look at something called composition of functions. The composition of functions is simply referring to input one function, take one function, and actually plug it into another function. So we are going to output something different. Okay, output a different function. So the notation for composition of function says f of g of x. Okay, this is not a circle, it's not a times. The way we say it is f of g of x. That implies function g goes inside the function f. Okay, f of g means g goes inside the f. Therefore, if I have a g of f of x, oh Lord, that does look like the word of. Alright, g of f of x, that implies function f goes inside the function g. So g is on the outside, function f goes in the inside. Okay, go in reverse. Okay. Alright. So find f of g of 4. Okay, what same thing as earlier, we got to find the composition of the two functions first before we can evaluate. So I'm gonna write it this way. I'm gonna write x right here. So f of g means g is inside x. Excuse me, g is inside f. So I will take whatever my function g is, substitute into function f wherever I see an x. There's only one right there. I will put it right there where the x is. So normally my function f says 2 times x. Now you will say 2 times x to the 3/2 power minus 2. And then don't forget, my function f still has a +3 there. Alright. So distribute, that's going to give me 2x to the 3/2 power. Okay, minus 4, then plus 3. So this is going to be 2x to the 3/2 power minus 1. Alright, x to the 3/2 power. Denominator determines the roots. Rational exponent becomes radical. So this is going to be a square root of x to the 3rd power. So this is going to be almost like it's going to be a radical function. Alright, now I'm going to evaluate. So this is my composition of two functions. Now I will evaluate at 4. So I seen student do plug in 4 right here, plug in 4 right here, right off the bat. No, we gotta put the function in there, then we evaluate. Okay, so I'm gonna write it out one time. 2 times 2, excuse me, 4, x is 4 to the 3/2 power minus 1. Two times 4, close parenthesis, raised into parenthesis again for the division, 3/2, then minus 1. Sorry. 15. Okay, 15 is my answer. Alright. If I will graph this function, 2x raised into the parenthesis, 3/2 power minus 1. Okay, this is a radical function. Yeah, not quiet. Just shoot up pretty quick up here. Alright, if I go to 4 for x, ooh, all these are, this is a square root function. All these are error right here. Let you look at it. See, if I set what's inside the square root into 0, x cannot be, you know, x will equal to 0. So my domain actually starts at 0. 4, 15. There you go. Okay. All right. Let's try another one. Now, the problem says, you know, round to 2 decimal places if necessary. So, you know, if you use the table a lot, then just make sure you round. Okay. All right. F of g of 9. Fg of 9. So, function g go inside function f. So let's find out what's the composition of the two functions first. Then we will evaluate. Alright, take function g, substitute into function f. Wherever you see an x, the only x is right there. So that will be a square root of 3 plus square root of x, whole thing squared, plus 1. Okay, now I can simplify this if I want to. Okay, I can simplify this if I want to. I'm gonna do it just to show you that. Just to show you what a domain can be like. Okay, let me show you. This is weird looking thing here. All right, this whole thing being squared. 3 plus square root of x, whole thing squared. Alright, so perfect square binomial tell me that will be my a squared plus 2ab. Take a number 2 times my a times my b. That will be 6 times square root of x plus my b whole thing squared. Square root of x whole thing squared will just be x. Okay, so inside this big old square root, I will end up with 6 times square root of x. Okay, plus x. Don't forget the plus 1. So this 9 plus 1 would be plus 10. Okay, very, very weird. Alright, so I can look at it this way, I can look at it this way. So where will my domain begin? If I set what's inside the square root equal to 0, and to see where my domain will begin, this is solving a radical equation. So I'm going to toss my x and the 10 over to the other side, so I can isolate my square root. That'll be negative x minus 10. Okay. I'm not gonna divide it by 6 yet because I don't want to make it into too many fraction looking things. So I'm gonna squaring both sides. Okay. If I will square both sides, 6 squared is 36. Square root of x squared is x equals. Alright, perfect square binomial again. My a whole thing squared is x squared. Alright, minus 2ab. 2 times my a times my b. So that would become positive x, I believe. Excuse me, it will be a positive term. It'll be positive 20x. Plus my b will be squared, which is 100. Alright, move the 36x over because now I'm having a quadratic equation now. So that's x squared minus what? 16x plus 100. Okay, let me make sure my sign is correct. If I will factor out both negative here, negative parenthesis x plus 10 whole thing squared, my sign could be off because the formula that we normally use for the perfect square binomial doesn't really including both of these are negative, so my sign can be off here. So let's check it. Normally it's supposed to be x squared plus 20x plus 100. So if I will, no. Okay, negative first. Yeah, you'll be positive again. Yeah, it's a little bit tricky. How about I do it like this? I want to make sure my signs are right, because if my signs are off, the quadratic equation here will be off. If I actually fold it out, I think I'm right. Negative x times negative x, positive x squared. That's negative. That's positive. That'll be positive 20x. Inner and outer is positive 20. Yeah, it is right. 16. Let's see. Let's see if I can factor this. I don't know. 10 times 10 obviously is 100. Besides 10 times 10, can 8 go into 100? 100 divided by 8. Nope. 6? Nope. Gotta be 5. 5 and 20. Nope. That ain't no 16. That's 15. So I don't even think this can be factored. Alright, besides 5, I can use 4. Maybe 4 would be lucky. Nope, 4 and 25, too far away. This problem cannot be factored. Ooh, my domain gonna be weird if this problem ever asks me that. Okay, so I want to show you, with the domain. The domain for this problem will be very strange. Okay, just so you know. Alright, it want me to evaluate, so I'm showing you all this just in case if there's a problem ever pop up where it will ask you to find domain. It won't be something this nasty, I don't think. It should work out. Alright, let's evaluate. And I'm gonna graph it. Evaluate 9. And here's a little trick. The one you graph is the one that you first set up. Okay, when you first write this thing out, before you simplify it, that is actually the one you want to graph. Okay, especially dealing with a rational function. Okay, composition of two functions, if it ends up to be a rational, you want to graph the original one, because the one after you simplify will be what the graph will look like. But if you will actually look at the original one you first write it out, it still show you that it's a rational function. Okay, because the certain constraint still applies. Alright, square root. So inside my square root, there's a parenthesis, 3 plus another square root of x, close parenthesis for my square root, close parenthesis for my what? For my whole parenthesis that I opened it, squared, then plus 1, then close the outside square root. Look very bizarre. Okay, what was the domain? Can't be -1. I don't know. I don't think it's a -1. Does the domain start at 0? I know it cannot be -1 right here. This cannot be -1 right here. So, okay. So that's not too bad. Not as bad as I thought it was gonna be, because inside the square root there's another square root. So if that square root cannot be -1 already, okay, then this whole thing won't even start at -1. So 0 makes sense. Set equal to 0. The most inner part of a function. Okay. Rather than just set what's inside the square root into equal to 0, we can set the most inner part of a function equal to 0. That will tell me where I can start. Alright, let's go down to 9. Let's see what our answer is. 2 decimal place. That will be 6.08. Let me just make sure. 6.08. Yep. Okay. So just be careful. Some of the stuff can get nasty after a while. Alright. This one. Composition of functions. F of g of x. Okay. Same thing. Take my function g, put inside the function f wherever I see an x, which is right there. So if we write it out, let me move this up. F of g of x. That would be okay. Normally my function f is x squared. Now you will say x plus 1 over 3 whole thing squared plus 3. Okay, and simplify your answer. Now this is not as bad as it seems. Okay, this is not as bad as it seems. Okay, because this is not really a rational function right now. Okay. Alright, I gotta square both top and bottom. Square the bottom is easy. 3 squared is 9. Square the top, that would just be x squared plus 2x plus 1. Perfect square binomial. Then plus 3. Alright, let's make it into one term. 9 times 3 is 27. X squared plus 2x plus 1 plus 27. That would be x squared plus 2x plus 28. Whole thing over, denominator is still going to be 9. Right? Okay, the little ancient Chinese secret, okay, that I might have mentioned before. When you combine a whole number with a fraction, you can always use that same trick like you would convert mixed number to improper fraction. 9 times 3, 27, to the numerator plus 27. That'll give me that 28 right there. Alright, so that's it. Okay, this is as simple as I can make it. I know there's no need to factor out the numerator. If it's factorable, there's no need. I don't even think this is factorable. Because there's not going to be any 9 coming outside the parenthesis to cancel out with your 9. So I know this is the simplest answer. Find a domain. Gotta find a domain for this. Let's graph it. Let's see. This is really not a rational function, okay? Because this over 9 can be put up front and be viewed as 1/9 times the quadratic function. This is actually a quadratic function. That's what we'll notice. This is going to be a u open upward. Okay. I'm going to put everybody on top in the parentheses to view as one term. X squared plus 2x plus 28. Close the parenthesis, divided by 9. See, this is a very wide, open very wide u. Okay, so my domain, there's no restriction on the denominator because denominator is just simply a 9. So my domain would just be from -infinity to infinity. Okay. All right. F of g. Okay, let's go backwards. F of g. Oh, sorry. F of g of x. So now this time I will actually put function f into function g. Wherever I see an x, only right there. G of f of x. So this x is only, it's just a positive 1x to the first power. So I don't need extra parenthesis to protect it. So that'll just be plus 3. Still got my plus 1 here over 3. So this is actually another quadratic function. So that's x squared plus 4 over 3. And so if you take this over 3 to the front, that will be 1/3 times this numerator. So that's why we know it's a quadratic. So not going to open as wide as the previous one. Parenthesis x squared plus 4 and then divided by 3. Here we go. So another u. Okay, so my domain is going to be from -infinity to infinity. Okay. Now, earlier I mentioned something about when you graph these composite functions, you want to graph the original one that you first set up before you even simplify. So what I mean by that is this is the one we're supposed to type in the calculator. Okay. The reason why I did not do that is because I knew from the very beginning this is a quadratic. So I know I'm going to have my u no matter what. So once I see my answer, it confirms that it is going to be a u open upward. What we need to watch out for, if this is not a 3 but rather than a 3x, so that is a rational function. So when you first write it out, if there's like an x down here, then this is going to be a rational function. So we got to watch out for that restriction on the domain. So that's why we want to graph the original function. Okay, just in case we ever run up, just in case if we ever run into it. All right, so let's see. All right, let's check out these two. These two function here. Alright, f of g. So this one won't be that bad, I don't think. Okay, function g, put inside function f. Wherever I see an x, right there. So that will give me square root of this x is 1x to the first power. So there's no distribution, there's no protection for negative sign, so I can simply write down x squared minus 5 and still plus 1. So this is going to be square root of x squared minus 4. Alright, this is going to be a square root function. Before I even graph it, I know that's going to be a square root function going this way. If I set what's inside the parenthesis equal to 0, okay, to do my domain and range, x squared minus 4 equal to 0. This is a difference of squares, so that will give me plus 2 and minus 2. So this is kind of weird though. One of my x is negative 2, the other x is positive 2, so I cannot have two starting points. Let's graph it. Hold on a minute, what's going on here? This is not just simply a square root, because there's an x squared right here. I think that will change the problem up. Oh, it's one of these. It's two of them. Okay, okay. So by looking at it, so this side keep on going left, this side keep on going to the right. So coming from left to right, this got to be my negative 2, and this got to be my positive 2. Alright, is it okay to have positive 2? Yes, it does not make the whole thing negative. Okay, so the negative 2 and 2 is actually on the line. It's actually part of my graph. Therefore, my domain got to be coming from negative infinity all the way to negative 2 using a bracket. Union. There's nothing in between, because a number in between is actually what makes it undefined. The other side starts from 2, keep on going to infinity. Okay. Alright, I think the step number 2 is vice versa. So let's check it out. G of f means take function f, put into function g. Wherever you see an x, which is right there. So normally my function g is x squared. Now it will be square root of x plus 1 whole thing squared, and still minus 5. Okay. Alright, so if I will simplify this, square and square root will cancel out. That will simply be x plus 1 minus 5. So I know this is going to be just a linear function, x minus 4. Okay, now check it out. I'm going to graph the original part that I first write it out. Okay, slope is 1, y-intercept at negative 4 by looking at my final simplifying part. So if I will do parenthesis square root of x plus 1, close parenthesis for my square root, close parenthesis for my first term, whole thing squared, minus 5. There you go. Hold up. That ain't no complete straight line. If I set what's inside the function equal to 0, this actually is saying x will begin at negative 1. But if I will actually grab x minus 1, it will actually be a whole straight line. So That's the reason why I mentioned before, sometimes we got to start out with what? This one right here. Okay, when we first write it out, that is the composite function. We simplify it to be the answer, but as far as the graph concerned, you need to graph this one. How about that? Confusing. Because most of the time, our first instinct is graphing the final answer. Our first instinct is supposed to graph the what? The part when we first write it out. So this is not, this is not quite a linear function, is it? Okay, make sure I didn't type in it wrong. Yeah, I started my square on the outside. Yeah. So my domain is actually from -1 to infinity. Let's check back up here. The first thing I first wrote out, square root x to the second power minus 5 plus 1. Close it. It's the same picture. Why? Because all these guys were inside the square root. Were all inside the square root function. So I know when I said was inside the square root equal to 0, my start and stopping point is correct. Oh. Okay. So be careful. Be careful. All right. So the 3 plus 1 becomes a 4. So this is actually the same as this original problem. So watch out. Okay. So now I remember why I leave this problem at the very end, because the domain is off. So if you will graph this problem by looking at the final answer, you will never notice it's a straight line, but it's actually not completely a straight line. Okay, so make sure when we do domain and range for composite function, graph the part that you first set up. Graph the composite function you first set up before you simplify them. Okay, that will give you the more accurate domain for the function. Alright, that will do it for this lecture video. Thank you for